We are still on the journey of motion. Welcome to Physics Mail. Today on Physics Mail, we want to carry out some calculations using velocity time graph. That's what we want to do. So we have treated various aspects of velocity time graph. We have taken our time to explain different things as far as velocity time graph is concerned. So in this video, our interest is to start solving problems. So let's do a calculation now on velocity time graph. All right, we're given a question. Example 1. We're given a graph. They say in the above velocity time graph, find the acceleration, the deceleration, the distance covered during what? During acceleration. So let's look at that together. Let's look at it together. Okay? Now, we still remember in our last video how we find acceleration. So we are looking at acceleration first. We say that acceleration is the slope of velocity what? Velocity time graph. That's acceleration. So acceleration A is the slope, and we give the expression V2 minus V1 equals T2 minus T1. That's our acceleration. That's acceleration. V2 minus V1 equals all upon T2 minus T1. Now we say in acceleration we have 2 points. The starting point, this point is usually the origin, that's 0. The starting point and the end point. So at every point we have a velocity, and we also have what? Time. At every point we have a velocity and we have what? Time. So this is the starting point. So we have the first velocity and the first time here. So we need to identify them. Now at this point, this is the origin. So 0 and 0. Both the time and velocity are 0 here, because if you trace this horizontally, you get velocity 0. You come down here, you get the time to be 0. So from here, T1 is 0 seconds and V1 is 0 meters per second. So that is the time and the what? And the velocity at this initial point. Then, remember, that's the formula. For us to use this formula, we need to obtain this. And we have obtained T1 and V1. Let's obtain T2. We'll go to the second point. This is point 2 of the velocity time graph. That's point 2 of the velocity time graph. So to get T1, from this point, we go to the time axis. So what is the T2 now? From this second point of the acceleration, because acceleration started here, and then that's the end of the acceleration. So to get the second time, we move down to the time axis. And what is the time here? Time here is 2. So T2, so the time here is 5. It's 5 seconds. Now what's the velocity at that point? This is that point. Trace it to the velocity axis. What do we have here? 25. We have 25 meters per second. So acceleration A will now become V2 minus V1, which is 25 minus 0, all upon T2 minus T1, which is 5 minus 0. So A becomes 25 over 5, which will give me 5 meters per second square. So that's my acceleration. So B, we're asked to find deceleration. Deceleration A is the negative of V2 minus V1 all upon T2 minus T1. So we'll still move to the acceleration, region of acceleration. That's the region of acceleration. That's the starting point and that's the end point. So this is point 1. So here we have T1 and then V1. From this point, we're going to obtain the first time and the second and the first velocity. So how do we get our T1 here now? T1 is here. We'll move down to the T-axis. That will give me 50 seconds. Okay? How do we get our V1? From this point, we move to the velocity axis. From that point, we'll move straight, and then our V1 becomes 25 meters per second. Then, how do we get T2? This is the end point. The second point, now this point 1, this point 2 for deceleration. At this point, we move downwards to get our time. And what is the time at that point? It is 60 seconds. How do we get V2? From that point, we move to V axis. And if you move straight to v-axis at this point, you will get v-axis at this point, and at this point v2 will now be 0 meter per second. So if we substitute, a becomes what? Minus bracket v2 now is what? 0, v1 is what? 25, all upon t2 is 60 minus 50. That will give me minus bracket minus 25 over 60 minus this is 10. So negative times negative is what? Is positive, all upon 10. This will give me 2.5 meters per second square. That will be our deceleration, 2.5 meters per second square. Okay. So the final thing we're asked to calculate is the distance covered during what? During acceleration. So we'll clear this place. Distance covered during acceleration. So C, part of the equation. Distance covered during acceleration. So we'll go here. Look at our acceleration. So what is this shape? Remember, we said to calculate distance from velocity time graph, it is area under the shape. So we must know the shape in order to get its area. So what is the shape? The shape is triangle. So we can say that distance covered during acceleration will be equal to area of a triangle, as we can see there. So it means that the distance covered during acceleration will be equal to half base times height. So what is our base? From here to here is the base, and from here to here is the height. So from here to here is 5, because 5 minus 0 is 5, so the base is 5. So we can write out the B is 5. And what is the height? The 5 is actually in time, so it's going to be 5 seconds. Height is from here to here, which is actually from here to here. It's in the vertical direction, so it aligns with the velocity axis. So the height will be 25 meters per second. So what will now be our distance? So the distance covered during acceleration is 1 over 2 times the base is what? 5 times height is what? 25. So 5 times 25 will give us 125 divided by 2 will actually give us 62.5 meters. That's what we are going to have, 62.5 meters. So the distance covered during acceleration is 62.5 meters. That's quite simple and nice. So we are going to go on a break. When we return, in the next part, we are going to look at another example, and then after that, I will give you a take-away question. Don't go too far. Remember, I'm still your friend and your tutor, Engineer Iko. Bye.